Hello everyone, mayong buntag natong tanan. So we have again another method of integration that involves trigonometric functions. This is a second group of transformation now where we have the powers of sine and cosine. So if this is the one appearing in our given and this is our general form, so the integral of a sine raised to power m multiplied with a cosine u raised to power n, where our u is a differentiable function in x. So we have to recall this. So these two are being paired because sine can be a differential of a cosine and cosine can be a differential of a sine in order for us to possibly apply the power rule of integration. So the differential of sine u is equal to a cosine u du. The differential of a cosine u is equal to minus sine u du. So if ever one of the function or any of the function here will serve as our u, the other function will be considered as its du. So we have to transform in a way that one function will contain a certain power and the other function will contain a power 1 in order to follow the u du form and in order to use the power rule of integration. That is if the exponent we have of our function is any constant other than negative 1. So, if this is a situation given, if ever this is a term you arrive, no, as we transform, there is the integral of a sine raised to power 6, cosine multiplied with the cosine x dx. So, our u is a sine x function, and our n is 6. What's the du? The du is the cosine x dx. So, there is already a u to power n and a du form. So, we can follow the power rule of integration. We can increase the power to 7. So, sine raised to power 7 over 7 plus c. So, in order to transform, so the transformation is in accordance with the following. So, we have three cases to consider. Case 1, in our general form, the power of our sine function is the one which is containing a positive odd integer while n can be any number. If we say it's any number, there is even a possibility that your n becomes 0. So what is important here is that there is a sine function with a positive odd integer power. So it may be that only sine function may appear in our given. That is, if your cosine has a power of 0. But any number can be used as a power of a cosine. So, transforming in a general term, if there is a general form following that case where our m is odd, we can convert that odd power to even by removing a factor of a sine u together with a dx. So this is now an even exponent by reducing with 1. A minus 1 becomes an even power from originally odd. Now we have to reduce the terms within the parentheses as powers of a cosine. And if this is already even, so we can use a transformation formula to convert everything in terms of a cosine using the Pythagorean identity. Sine squared u can be replaced with 1 minus cosine squared. So, with that, we are now ready to solve for a situation like this. Now, take note that the power of sine is odd, and that is 3. This is the least value for the odd power of sine. Because if this becomes 1, or that is sine 2x only with a power 1, then there is no need to transform because we are already provided with a u du form. No? Or maybe there may be a lacking constant factor in order to have the u du form be exactly followed. Okay, that is if the power is 1. But this is cube, so that is governed under case 1. I'll be reducing the power of sine from 3 to 2, no? By factoring out a sine function. And take note that the sine function is a differential of a cosine. So that means, in order to use this as a du of a cosine, so everything here will be expressed in terms of a cosine. Sine squared can be replaced with 1 minus cosine squared. Okay, I'm now transforming 1 minus cosine squared for the sine squared. So multiplied with a cosine of 2x raised to power, equivalent fractional power, that's 1/4. And then I can distribute the cosine raised to power 1/4 to the transformation formula being used, no? So, we have terms which is a cosine raised to power 1/4 when it's distributed to 1. I can add 2 and 1/4 because these are all cosine, and we have cosine raised to power of 9/4. I have sine 2x, so this is intended as the common differential of a cosine 2x. Cosine 2x as my u, while these are n. So the du of which is equal to a negative sine 2x to dx. Or say, we have a negative 2 sine of 2x dx as my du. Checking on this expression, obviously it's lacking with minus 2. I can insert a negative 2, but I have to put a neutralizing factor before the integral sign, a negative 1/2. So this is now the resulting expression after inserting a negative 2 and neutralize with a negative 1/2. This is now taking a form of u to power 1/4 du, u to power 9/4 du. So I can now apply the power rule of integration, just increase 1/4 by 1 or 4/4 and increase 9/4 by adding 4/4 also. As a result, we have cosine raised to power 5/4. This is divided by n plus 1 also. Minus a cosine raised to power 13/4 divided by 13/4. I can distribute my 1/2. So I can obtain 1/2 times 4/5 because it's divided by 5/4. So I have a constant coefficient of negative 2/5 from the first term. Cosine raised or cosine 2x raised to power 5/4. This is also distributed 1/2 no, to the second term, that becomes plus. This is 4/13 times 1/2, or that can be 2/13 cosine 2x raised to power of 13/4 plus c. You can also give an equivalent expression to contain radical. Okay, so instead of having 5/4, I take it as a fourth root of a cosine raised to the fifth power. This can also be a fourth root of a cosine raised to power 13. So that is if we have to give our answer in terms of radical form. Another way of presenting answer is to apply factoring. Between constant coefficient, I have a common factor of 2. I also have a least common denominator of 5 and 13, which is 65. So I can remove minus 2 over 65 together with a cosine. Consider the lowest power because we are taking a common factor. Okay, so that is minus 2 over 65 cosine raised to power 5/4. First term, if you divide, no, so that is 2/5 or minus 2/5 divided by minus 2 over 65. The result of which is 13. Cosine is out. They are exactly the same. Okay, and this is a negative. So if you have to divide also 2/13 with 2/65, you have 5. The cosine with power of 13/4 is subtracted with 5/4. This we're able to produce 8/4 or cosine squared. Okay, so this can be our answer if we take that in a factored form. You may also give this in a form of radical if you like. So that's how to give the answer. So we have powers of sine, which is add. In case number 2, the add power belongs to the cosine. In order for us to shorten this recalling process, no? So in powers of cosine and sine, so case 1 and case 2 may be combined. Just look only for an add exponent, either belonging to sine or a cosine. If both are add, then you have to transform the one with least value of its exponent so that the transformation will be easier. Okay, power of cosine is the one which is add, while m can be any number. So if that's the case, the add exponent of the cosine will be made even by removing 1. And the cosine is factored out. We know that the cosine is a du of sine, so everything here will be expressed in terms of sine terms. Of course, with different power because this is in preparation of using a power rule of integration. So if this is now an even exponent, a minus 1, then there is really a cosine squared to exist at this factor. So we can replace it with the transformation formula. So, it is substituted here and everything here will be in terms of a sine terms. And this is our example. The cosine is the one that bears the odd exponent. The sine here does not appear because it is containing a power of 0. What is important is there is one factor or there is one function, either cosine or sine, that bears an odd exponent, positive odd power. And that is on cosine because we are now working in case number 2. Make this even. I have to remove a cosine factor out from that. That becomes cosine raised to power 6. Okay? So if that is already even, then there must always be a cosine squared to exist. If this is cosine squared and that is raised to power 6, so it means there is cube outside. And I can change my cosine squared. No, this is again intended to become a du of a sine function. So, cosine squared is replaced with 1 minus sine squared. But I need to expand this, no? Because this is raised to 3. So, medyo dugay pagtrabaho kung ang imong power magkadako. If this becomes 9, the more it will take time to do the integration. Okay, I'll be expanding my binomial. I'll be guided with a binomial expansion with a power of 3. So, my first term is in cube and my second term is minus 3 square of the first term multiplied with the second term plus 3 a or my first term raised to 1 then square of my second term then minus b cubed. If that's plus, then all of these are in positive sign. Plus, minus, plus, then minus. E is descending while b is ascending. Every term is homogeneous. That means every term has a degree of 3. If the power here is 3, the number of terms is 1 greater than this exponent. So here is the expanded form. Cube of 1 is 1. I have 3, 1 squared, then put the second term, sine squared. So I have minus 3 sine squared, the same angle, x over 3. Plus, I'm now in my third term, which is 3a b squared. So 3 times 1. The square of sine squared is sine to the fourth power. And I have the sine raised to 2, so which is in cube. So my last term is sine raised to 6. So expected that all the terms here must be a sine term in order to have this as my du. But if you have to look, my first term is different because my first term is a constant term. So I cannot use a power rule of integration for all the terms because of this. So this term will be treated under a different formula. So if I'm going to distribute my cosine, so I have to integrate a pure cosine term. Then the rest are all involving sine function. Okay, so I just copy, I put plus and copy all the terms. Now, I put plus in order not to change the sign of the terms after my integral sign. Okay, so here, my u is x over 3. What's the du of 1/3 of x? That is 1/3 dx. While for the 3 terms involving sine, my u is the sine of x over 3. My du is 1/3 of a cosine of x over 3 dx. So there is a factor that is lacking. This is lacking with 1/3, 1/3, so neutralize with 3. If this is inserted with 1/3 also because of this, then I'll be neutralizing that with 3. Okay, so here, we are now inserting the different lacking constant factor with the neutralizing factor. This is inserted, that is neutralizing factor. 3 is inserted, 1/3, 1/3 is inserted, neutralizing factor is 3, the reciprocal. I have 1/3 being inserted, no? So that is lacking in every term. So we have a common neutralizing factor also of 3. What is the integral of a cosine u, du? That is sine u. So that's why we have 3 sine of x over 3. I'm now working with the terms involving sine. So I'm now increasing this to 3. And it's divided by 3. So if this is 9, so that's why there is 3 that is left. This is supposed to be 9. I'm increasing this to 5. Divide with 5. That's why I have 9 over 5. I have 3 being distributed here. This is increased to 7, correct? Then that's divided by 7. Okay, so this is now our final answer. That is if the exponent of a cosine is odd. Now here is the case number 3. In a general form, then the exponent of sine and cosine can be all positive even integer. Or it may be only one of the function may excess with even power and the other exponent is 0. Or it could be n is a positive even integer and m is 0. Now what are we going to do if there is a positive even power to sine and cosine? There is a power reducing formula for sine and cosine because in the list of integration formula, there is no other function that contains power up to except for the secant and the cosecant. Okay, so here is the power reducing formula. For sine squared u or the square of sine u, then we can replace it. By the way, this is minus. This is 1 minus cosine twice u. So, if this is u, just double. Okay, then that is all over 2. Or if I have to take every term, no, so this is 1 half. That's also minus 1 half of a cosine of a double angle. So, if this is u, so just double the angle in the cosine terms. If that is a square of a cosine u, then the formula will be the same except the sign is from negative, it becomes plus. Separating every term by dividing with 2, 1 half plus 1 half, a cosine of the double angle. Okay, here is the application of this transformation formula. Now, if the exponent is much greater than 2, then you can arrive with an integrable form directly, but you need to have a repeated use of the transformation formula until all becomes integrable. Here is the example. I have a cosine or a square of a cosine where my u is 3y. Solution. So that's equivalent to 1 half plus, I'm using this now, plus 1 half, the cosine double the angle here, whatever angle you have, and the square of a cosine. So, if that is 3y, it becomes 6y. Then, I have to integrate every term under some rule. I have 1 half of dy, integral of dy, plus 1 half integral of a cosine 6y dy. First term is integrable as 1 half y. The second term, I need a u and a du form. My u is 6y. My du is 6 dy. So, 1 half of, I'm inserting, by the way, 6 and balance with and neutralize with 1 over 6. Actually, this part here may be skipped, no? To shorten the process of solving. Even here, no? You can skip that one so that you can save time. So, I have 1 half of y plus 1 over 12. The integral of a cosine u du is sine u. So, sine of 6y plus c as my answer. So, it will take time if the power will be increased. Say, I have a sine to the 4th power. It means there is sine squared. And again, that is raised to another power 2. So, replacing sine squared with this one, again, this is 1 minus a cosine of the double angle. Okay, I may use this one because I still need to expand. Okay, para I won't be working with terms involving fraction. So, use this one if there is still an expansion of your binomial. Okay, now, I have 1 minus cosine. I double the angle from 2x, it becomes 4x. It's over 2. This is for the sine squared of an angle 2x. So, square. If you take the square of the denominator, then this becomes 1/4. I just put my 1/4 outside and expand my binomial with a power of 2. 1 minus 2 cosine of 4x plus cosine squared 4x. So, these two are integrable. But there is still another cosine squared. So, I can further replace this with the transformation formula. That is why there is a notation below that you need to apply the transformation formula until everything will become integrable. So, here, I am replacing again the cosine squared with 1 half plus 1 half cosine of twice 4x becomes 8x because that is to be doubled. Okay, so I can add 1 and 1 half. That's why I have 3 halves. I have minus 2 cosine of 4x plus, okay, so remove the other plus sign that is duplicated. So that is plus 1 half of a cosine of 8x. So I have to integrate every term. First term under sum rule. So this can be 3 over 8. I have to integrate a dx. This is distributed. Okay, so 2 and 1/4 is 1 half. So I get a 1/4 here because my u here is 4x and my du is 4dx. So there is an insertion of a lacking constant 4, so 1/4 is also provided. Here, I have 1/4 with 1 half, that becomes 1 over 8. Okay? And I am inserting it because my u is 8x and my du is 8dx. So this becomes 1 over 64. When integration is made, the integral of cosine is a sine function. Cosine is also sine, then this is x. So this is now our final answer. But it is not the final example yet. I still have one because what I'm after here is only for you to familiarize the different transformation to be made and the different identities we are using. There is sine squared and a cosine squared. I'm not going to replace this with this individually because I also notice that their angles are the same. If their angles are the same, then we can have a product of sine and cosine raised to a common power of 2. Okay, so we can do it that way. So that is the product of sine and cosine raised to 2. I can make it simpler. Instead, actually, you can use this directly. But it is simpler to have this. If I'm going to look for a double angle formula containing sine function, the sine of the double angle is equal to twice the product of sine and cosine. But what exists here is a product of sine and cosine where there is an absence of a constant factor 2. So, if this is the one appearing, then that is equivalent to half of the sine of double angle. Okay? So, I'll be replacing this with 1 half of a sine of double angle. So, 4x would be the replacement, would be the new angle if I'll be using this one. Okay, so here, we follow the double angle formula. There's 1 half because of this. Then we have sine double. That's why we can have 4x instead of 2x. This is in square. So if I take the square, there is 1/4. And there is sine squared. The sine squared can now be changed to 1 half minus 1 half a cosine of double. So it becomes 8x. So there is 1 over 8. Correct? When I distribute 1/4. There is also 1 over 8. Integral of cosine 8x dx. But I'm inserting it so we can neutralize by having 1 over 8. And then we can now apply the formula to finally do the integration. 1/8 x minus 1 over 64. The integral of a cosine u du is sine u or sine of 8x plus c. So that's all. And thank you for watching. So I hope everything is clear to us. Okay, so do not forget to share. Subscribe for those who are new to my channel. So I will be happy to see more subscription. Okay, so thank you and goodbye.